So, let's go. The most terrifying thing about the Artemis 2 mission isn't what the crew found on the moon. It's what they found on the way back, and on the way there, and in their own bodies. 4 astronauts went farther from Earth than any humans in history, and what they came back with changes what we thought we knew about the moon, about space, and about whether we can actually survive out there long enough to matter. 5 discoveries, some of them were planned, some of them weren't. All of them are genuinely unsettling. Number 1, the shield that shouldn't have flown. April 10th, 2026. 4 astronauts are hurtling toward Earth at 24,600 miles per hour, Mach 33. Fast enough to cross the entire continental United States in about 6 minutes. The outside of their capsule is 5,000 degrees Fahrenheit, roughly half the surface temperature of the sun itself. A sheath of superheated plasma wraps around the spacecraft and severs all communication with the ground. For 13 minutes, Mission Control can do absolutely nothing but stare at screens and wait. And here's the thing. They knew going in. The thing that had been quietly terrifying NASA engineers for 2 years. The heat shield protecting those 4 people had a known flaw, not a theoretical flaw. A demonstrated, documented, photographed flaw, and it hadn't been fixed. Go back to 2022. NASA sends the same capsule design on an uncrewed test flight. Artemis 1, no crew, just a practice run. The mission goes well, the capsule splashes down. Engineers pull it out of the Pacific and start inspecting the heat shield, which is supposed to look charred and a little rough, but structurally intact. What they found instead looked like something had taken bites out of it. Over 100 cracks, deep gouges, chunks of material missing, not worn away smoothly but blown off in pieces. The heat shield is made of a substance called Avcoat, a carefully engineered blend of resin and silica fibers that's supposed to slowly char and burn away during re-entry in a clean, controlled process, carrying heat away from the capsule as it goes. Think of it like a slow, deliberate sacrifice. The outer layer gives itself up, so the inside stays intact. That's the design. That's what's supposed to happen. It did not happen that way. NASA spent the next 2 years trying to understand why. What they eventually found was almost embarrassingly mechanical. The shield couldn't breathe. Here's what that means. During re-entry, the inner layers of the Avcoat get extraordinarily hot and start chemically breaking down, a process that generates gas. Under normal conditions, that gas filters up through the porous outer char layer and escapes harmlessly into the airstream. But during Artemis 1, the outer layer hardened too quickly, sealing itself off before the gas could get out. Pressure built up in the decomposing layer underneath. And then, chunk by chunk, the trapped gas blew pieces of the heat shield right off the spacecraft, over 100 locations. Any one of them, if the geometry had been slightly different, could have allowed re-entry heat to burn through the capsule wall. Now here's the part that makes it worse. By the time NASA fully understood the problem, the Artemis 2 heat shield was already built and installed. They couldn't go back. And this is the detail that made some engineers genuinely uncomfortable. The Artemis 2 heat shield was actually less permeable than the Artemis 1 version. 0% permeable compared to the 6% that had survived intact on the previous shield. They had made it less breathable on purpose to make factory quality testing easier. So the mission was carrying a more airtight version of the thing that had already failed. The fix they landed on was to change the re-entry trajectory. Instead of the deep skip maneuver Artemis 1 used, dipping into the atmosphere, bouncing back out, then coming back in, Artemis 2 would use a shallower loft profile. Less time in the temperature zone where the gas buildup happened, less stress on the Avcoat, the theory being that if the outer char layer stayed permeable enough for long enough, the gas could escape and the shield would hold. It was a fix made of math and hope, applied to hardware that was already installed and couldn't be swapped out. Charles Camarda, a former NASA astronaut and the kind of heat shield expert you call when you need someone who actually understands this material, said publicly that they should never have launched. He'd flown the first shuttle mission after Columbia specifically because of his heat shield expertise. He knew what motivated institutional reasoning looked like when it was dressed up as engineering confidence. He wrote to NASA leadership that history shows accidents happen when organizations convince themselves they understand problems they don't. He wasn't alone. An independent review was conducted. Some of the reviewers were satisfied, others weren't. The mission flew anyway. There's no escape system during re-entry, no abort option, no ejection seat, no last resort protocol. Once the capsule hits the upper atmosphere at Mach 33, the crew is committed. If the heat shield fails at peak heating, the outcome is the same as Columbia. Everyone in mission control knows this. The crew knows this. Victor Glover said he'd been mentally living in that re-entry moment since the day they announced his assignment. Not from fear exactly, more like the specific focus of someone who has identified the exact thing they need to survive. They survived. Splashdown April 10th, clean and on target. 4 crew green, Wiseman reported from inside the capsule. All 4 of them okay. But here's where it gets strange. As of when this video was made, the full heat shield inspection wasn't complete. Engineers were still scanning it, still comparing data. We know it worked. We don't yet know what it looked like when it came out of the water. That answer matters enormously because Artemis 3 is already being planned, and the lessons from this heat shield, whatever they turn out to be, go directly into that mission's design. The shield held, and the next question is, by how much? Number 2, the moon is getting hit constantly, and nobody expected that many. Rewind to April 6th. The crew is in the middle of something that, by any reasonable definition, should already be the highlight of the entire mission. A total solar eclipse, not viewed from a field with cardboard glasses, but from 4,000 miles above the lunar surface, the moon itself blocking the sun, the corona glowing around the edges like a white crown in absolute black. Astronaut Reed Wiseman got on the radio and said he was going to need to invent new words. He wasn't being poetic, he literally ran out of adjectives. But then something else started happening on the darkened surface below. Flashes, small, sharp, and gone before you could fully register them. And then another one, and another. 6 of them. In under an hour, meteoroids slamming into the lunar surface in real time. Not ancient craters, not geological history. Live impacts happening right now while 4 humans watch from orbit. Wiseman called it in immediately. That was definitely impact flashes on the moon. And Jeremy just saw another one. Down on Earth, lunar science lead Kelsey Young later told reporters that she hadn't really expected them to see any. She described her reaction in the moment, surprise, then pure scientific delight. Mission Control had what one crew member called audible screams of delight when the reports started coming in. Here is the moon's dirty secret. It absorbs roughly 100 tons of debris every single day. Dust, pebbles, fragments of rock and metal, everything from microscopic grains to objects that would fill a room, all of it arriving at full cosmic velocity. On Earth, almost all of that burns up in the atmosphere before it gets anywhere near the ground. On the moon, there is no atmosphere. There is nothing between the surface and the incoming debris except open space. Everything that hits at full speed. From orbit, you almost never see it happen in real time. The events are brief and geographically scattered across a surface that's bigger than the continent of Africa, catching 6 in under an hour from a spacecraft window while also watching an eclipse. That was not in the mission planning documents as an expected outcome. And here's why that number matters beyond the spectacle of it. Scientists are now trying to work backward from what the crew described, brightness, duration, any color, to estimate the size of the impactors. Planetary scientist Bruce Betts put it plainly, whatever made those flashes was not dust. But it also wasn't a boulder. Something in between, arriving repeatedly on a schedule nobody had documented with this kind of direct human observation. The researcher who maybe said it most directly was Peter Schultz from Brown University, who has studied lunar impacts for decades. His response to the Artemis 2 data: the daily flux of meteors needs to be understood a lot more carefully before anyone establishes permanent infrastructure on that surface, because the Artemis 4 crew isn't watching from 4,000 miles up. They're landing. They're getting out. They're setting up equipment and conducting science operations for days at a stretch, and the only thing between them and whatever is falling out of the sky is a suit rated for vacuum and temperature. not for being hit by a fast-moving rock. The moon is not the quiet frozen museum piece we built up in our heads during the decades when nobody was going there. It is being actively bombarded right now while you're watching this. The Artemis 2 crew watched it happen live from orbit. And the number 6 is going to appear in a lot of future mission planning documents. Number 3, the far side has never looked like this, and it is stranger than we expected. Before the eclipse, before the impact flashes, the crew passed behind the moon entirely. 40 minutes of complete radio silence, the moon's entire bulk sitting between the spacecraft and every antenna on Earth, blocking every signal in every direction, no contact, no telemetry, no way to know if they were still alive. They were 252,000 miles from home, the farthest any humans have ever been. And they were completely alone with the far side of the moon filling their windows. When they came back around and communications restored, the reports started flowing in. They'd seen the Orientale Basin, 600 miles wide, 3.8 billion years old. A multi-ring bullseye impact scar sitting right on the boundary between the moon's near and far sides, formed when something enormous hit the early moon and sent shockwaves rippling outward in concentric rings that we can still read today. The largest young impact basin on the lunar surface. And the first time any human being had ever seen the whole thing at once from space with their own eyes. Wiseman described the outer ring as looking like a kiss on the far side of the moon. Jeremy Hansen said what shocked him most was the three-dimensionality, the way it actually looked like a real physical place instead of a flat photograph. Something that just shocked me, he said on the radio, is just the three-dimensionality of it. The science team on the ground wasn't just collecting awe. They were collecting data. Astronauts can detect color variations and surface texture differences with their eyes that cameras often struggle to capture in the same way. Subtle browns and blues that indicate mineral composition, that indicate age, that indicate the geochemical history of a specific patch of rock. You can't easily automate that. Trained human eyes, connected to trained human brains, looking at real terrain in real light, are genuinely scientifically useful. That's not sentiment. That's why the crew spent 3 hours specifically doing geology observations, and some of what they saw was almost like reading a clock. Giant chains of craters radiate outward from Orientale in long arcing lines, scoured into the surface by debris thrown out from the original impact 3.8 billion years ago. The crew could trace those chains across the surface, and they could see those chains crossing into an older formation called Hertzsprung Basin, a crater so old and eroded it barely registers as a basin anymore. The fact that Orientale's ejecta chains are etched into Hertzsprung's floor proves that Hertzsprung has to be older than Orientale. You can read which came first directly from the landscape. The crew was watching billions of years of geological history written in rock and calling it into scientists on Earth who were updating their notes in real time. But there's a much larger mystery sitting underneath all of it, and the crew's observations didn't solve it. They made it more vivid. The near side of the moon, the side you see every night, is covered in wide, flat plains of ancient volcanic basalt. Dark Maria, the remnants of massive lava flows that resurfaced huge sections of the lunar crust billions of years ago. The far side is almost completely different, heavily cratered with almost no volcanic plains at all. The same moon, the same original formation event, the same geological history up to a point, and then two completely different surfaces. Nobody knows why. This isn't a gap in the data. This is a fundamental open question in planetary science. Some researchers think the crust on the far side is thicker, making it harder for ancient volcanic material to punch through. Some think the early Earth's gravity influenced lunar volcanism in ways that created natural asymmetry. Some think a second ancient moon, a smaller companion body, once existed and eventually merged into the far side billions of years ago, thickening the crust and suppressing volcanic activity. That last hypothesis is not a fringe idea. It has serious support. It is also unproven. The Artemis 2 crew photographed and described features on the far side that had never been seen by human eyes in this kind of direct, unmediated detail. Scientists are still going through those images. Some of what comes out of that analysis may help narrow down the asymmetry problem. Some of it may just deepen it. The moon up close is stranger than anyone described. Number 4. The invisible threat that cannot be stopped. You can look at a rocket and understand it. You can look at a heat shield and hold a piece of it. You can see the moon through a window and feel the reality of it. Radiation is different. Radiation is invisible, odorless, silent. You don't know it's happening. You don't feel it happening. And by the time you have evidence it happened, it's already done. The Artemis 2 crew spent 10 days beyond Earth's magnetic field. Earth's magnetosphere is the invisible bubble generated by our planet's core that wraps around the planet and deflects the majority of incoming high-energy particles. It is the reason Earth is habitable and Mars is not. The International Space Station orbits inside that bubble. Artemis 2 flew outside it, past the point where the bubble's protection ends and open space begins. Out there, two things are trying to get into your body. The first is solar particle events, sudden eruptions from the sun that can flood the local environment with radiation in a matter of hours with very little warning. A significant solar flare went off on March 29th, 3 days before launch. The crew got lucky, no major storm hit during the mission itself, and NASA had solar monitoring, spacecraft watching the sun continuously throughout the flight, but a bad storm at the wrong moment is one of the genuine worst-case scenarios for any deep space mission. You can't outrun it. You can retreat to a more shielded part of the capsule, compress your schedule, take shelter, and then you wait and hope the dosage stays within survivable limits. The second threat is slower and quieter and in some ways more insidious. Galactic cosmic rays. High-energy particles born in supernova explosions across the galaxy, traveling at near the speed of light, hitting the spacecraft from every direction simultaneously. Not a beam you can angle a shield against. A drizzle coming from everywhere at once. And these particles are energetic enough that they pass through the walls of the spacecraft, through your clothing, and through your body, as if none of those things are meaningfully in the way. Apollo astronauts came back from the moon with unusually high rates of cataracts in later life. The leading explanation is heavy ion cosmic radiation passing through the lens of the eye and causing cumulative damage. Many of them reported flashes of light even with their eyes closed, especially during the translunar transit. High-energy particles physically passing through their retinas and triggering visual signals. One of the most surreal experiences in the history of human spaceflight, described matter-of-factly in mission reports, seeing light that was caused by radiation, not by anything actually luminous. Long-term studies of deep space exposure suggest links to cardiovascular damage and to brain inflammation associated with conditions like Parkinson's disease. These are not certainties, but they are documented patterns in a small population of people who have actually been where Artemis 2 went. And here's the part that has no good solution, the part that keeps deep space mission planners awake at night. You cannot meaningfully shield against galactic cosmic rays with current technology. A wall thick and dense enough to stop them would be so heavy the spacecraft couldn't fly. And making the shielding denser actually creates a secondary problem. Incoming particles hit the shield material and generate new particles that scatter inward. You can reduce the dose. You cannot eliminate it. There is no version of current physics where you build a wall and call it solved. So what do? You measure everything. You treat every mission as a data point. Artemis 2 was loaded with radiation sensors, 6 built into the capsule, plus personal monitors each astronaut carried in a pocket at all times. And then there was the experiment that might genuinely be the most scientifically significant thing that flew on that mission, even though almost nobody was talking about it during the launch coverage. Each of the 4 astronauts donated bone marrow cells before the mission. Scientists grew those cells on a small chip, a device about the size of a USB drive that can sustain living tissue and monitor its biological responses. 1 chip per astronaut flew to deep space inside integrity. 1 chip per astronaut stayed on Earth in a controlled lab environment. 10 days of identical biological material, 1 set exposed to the full deep space radiation environment, 1 set sitting safely within Earth's magnetic field. When those chips are compared under the microscope, for the first time in history, scientists will be able to see exactly what 10 days beyond the magnetosphere does to human tissue at the cellular level. Not inferred from post-mission health data years later. Observed directly in the cells themselves while the damage is fresh. Those results aren't in yet. When they come back, they will feed directly into the risk calculations for every future crewed mission beyond low Earth orbit. There's also this. Preliminary radiation readings from the mission reportedly came in around 18% higher than the pre-flight models had predicted. If that holds up when the full data is analyzed, it means the models were wrong and the wrong direction. Every future mission timeline, lunar surface stays, gateway station rotations, eventual Mars transits, gets more complicated if the baseline exposure is consistently higher than projected. 10 days of data. 54 years since the last time humans generated it. Whatever it shows, it matters. Number 5. The thing on the moon that shouldn't exist. On the way toward the moon, the crew passed over a feature on the near side called Reiner Gamma. It doesn't look like a crater. It doesn't look like a mountain. It doesn't look like anything else in the known solar system. It looks like someone took a broad pale paintbrush and swept it across the surface in long, curving arcs. Bright loops and swirls standing out sharply against the dark volcanic plains around them, hundreds of miles across, following curves that don't correspond to any geological boundary or impact structure or volcanic feature. It looks honestly like a crop circle. Except it's the size of a small country. It should not exist, and we have no satisfying explanation for why it does. Here's what makes Reiner Gamma genuinely strange rather than just visually weird. The moon does not have a global magnetic field. It used to, early in its history when its interior was still molten and churning, but that field faded billions of years ago as the core cooled. The moon is not supposed to have significant magnetism anymore, but Reiner Gamma sits on top of a powerful localized magnetic anomaly. A bubble of magnetism anchored in the lunar crust, producing a field strong enough to deflect the solar wind, the constant stream of charged particles flowing outward from the sun. That deflected solar wind means the surface under the magnetic bubble doesn't go through the same weathering process as the surface around it. The surrounding terrain darkens with age as solar particles react with the regolith. The protected area under the magnetic bubble stays bright. That's why the swirl pattern is visible. It's essentially a region of the moon that has been shielded from something that darkens everything else. Which raises an obvious question. Where did the magnetic field come from, if the moon isn't supposed to have one? 3 theories. First, a comet impact. A comet hitting the surface at high velocity could have magnetized the crust locally in the moment of impact. In the swirl pattern is the surface material disturbed by the outgassing of the comet's vaporized material. Second, ancient impact ejecta. When a giant object hit somewhere else on the moon billions of years ago, the debris that flew out and re-landed here was iron-rich and arrived while the moon still had its early magnetic field. It cooled in place and locked the magnetism in like a fossil. Third, the magnetic field is a remnant from the moon's own early active core, preserved in a patch of crust that somehow retained it when everything around it lost it. Each of these theories explains some of what we observe. None of them explains all of it. Researchers who have spent careers studying this feature have said openly that the origin probably won't be fully resolved for a very long time. There's never been a lander at Reiner Gamma. No mission has ever measured the magnetic field from the surface at ground level, with instruments sitting directly in the anomaly. Everything we know comes from orbit, from hundreds of kilometers up, and from the kind of inference-heavy analysis that leaves a lot of room for being wrong. We are looking at something continental in scale, completely unexplained, on the closest world to Earth, with 50 years of space exploration behind us. The Artemis 2 crew saw it from above. Future missions might land on it. And whatever answer eventually comes back from that landing will either confirm one of the theories we already have, or add a 6th terrifying discovery to this list. The heat shield inspection is still being completed, the organ chip data is still being read in labs, the impact frequency calculations are just getting started. The far side images are still being processed by geologists who are updating maps that haven't been updated since satellites started photographing the moon in the 1960s. And somewhere in all of that incoming information, in the biological data and the radiation readings and the photographs of features no human eye had seen before April 6th of this year, there are answers we don't have yet. They went, they came back, and the list of things we don't understand just got significantly longer.